All right, all my wonderful babies out there, time to do another review. We got our quiz next period, so let's make sure we know how to do every question that's on this review. Let's do a really good job with it. So let's go. The first section is simplifying radicals. I'll kind of do them off to the side here. Number one is the square root of 32. The process that we've taught you for this is to list out, or at least do in your head, the perfect squares. This is the list of options, right? The next perfect square, 36, is already too big. 25 times 2 is already too big. 16 times 2 is perfect. So I'm going to make this the same as 16 times 2. Why do we do that? Well, what is the square root of 16? The square root of 16 is whole number 4. So 4 root 2 is the square root of 32. Number 2 here is 5 root 75. Let's see what we got. 5 root 75, same process. I'm doing this in my head, but you can write it out if you need to. 4, 9, 16, 25, 36, 49, 64, and then the next one would be 81, which is too big. Well, 64 times 2 is too big. 49 times 2 is too big. 36 times 2 is 72, but it's not going to work out after that. 25 times 3 is looking real good. So the square root of 75 is the same as the square root of 25 times the square root of 3. And don't forget there's a 5 in front. So we have 5 times 5 would be 25, and there's a root 3 left over, right? The square root of 25 is 5. 5 times 5 is 25. That's how we did that. The next one, number 3, I'm going to put it way over here, but number 3 is root 50. Root 50 times 2 root 125. 2 root 125. There's a few ways you can go about this, but the strategy I taught you guys in class is to pull out a common factor. Root 50 is 25 times 2, and root 125 is 25 times 5. And don't forget there's a 2 there, so I'm going to list that out in front. Root 25 times root 25 is whole number 25. And then root 2 times root 5 is root 10. 25 times 2 is 50 root 10. So we pull out a common factor. Why do we do that? Because if it's the same radical twice, the radical cancels out. As a quick reminder, root 25 times root 25 is like root 25 squared, which is whole number 25. That's what I'm doing there. All right, the next one, number 4, is 7 root 15 over 5 root 21. The idea here is actually kind of similar to multiplication, but since we're dividing, now they're going to completely cancel out. So we're going to rewrite this as root 5 times root 3 on top, and as root 7 times root 3 on bottom. And I'm writing it out just so you can see it, but we're reducing the fraction. The root 3's would cancel out, leaving us with 7 root 5 over 5 root 7. So first job, anytime you're working with division, is reduce, reduce, reduce. You can reduce whole number with whole number. You can reduce radicand with radicand. Once you're fully reduced, then you gotta rationalize the denominator. We cannot have an irrational number, root 7, in a denominator. That is not considered the best version of this number. So I'm going to show all my work, but I'm hoping that you can do most of this in your head. I'm hoping that you don't have to show your work on this every time. But you would have 7 root 35 on top, and this is whole number 7. Root 7 times root 7 is 7. Times 5 would be 35. Don't forget to reduce. 7 over 35 reduces to 1/5. So this would be root 35 over 5 as your final answer. And then the last one here, we're going to break down each one. You can only add and subtract like terms. So in order to know which ones are like terms, we need to fully simplify each radical. The first one, I'm going to pull out a perfect square 4. 4 times root 4 would be 8 root 3. The second one, I'm going to pull out a perfect square 25. 25 times 7. 6 times 5 would be 30 root 7. For the third one, I'm going to pull out a perfect square, root 9. 9 times 3 is 27, but root 9 is 3, so this is like 3 times 3. So 3 times 3 would be 9, and we have a root 3. And then 2 root 7 cannot be broken down. Looking at this, we have a minus, a plus, and a minus. So we have positive 8 root 3 and positive 9 root 3 for positive 17 root 3. We have negative 30 root 7 and negative 2 root 7 for a negative 32 root 7. Woo! All right, simplifying radicals. Nice work. Let's keep it going. This is solving for the indicated side. So looking at this first one, we're looking for the right side. That's this side over here. And we know 2 of the sides are 8 and 10. And this is going to be a situation where if you can reduce, that's the easiest way to do it. 10 divided by 2 is 5. 8 divided by 2 is 4. And that is one of our triples. Don't forget to multiply the 2 back on. So if you have 2 sides of a triangle, you're doing Pythagorean theorem. And when you do Pythagorean theorem, it is always easiest to reduce first, do Pythagorean theorem on the small numbers, then multiply the scale factor back on. Because this was a triple, 3, 4, 5, I didn't even have to do Pythagorean theorem. I have that one memorized. Over here, we have a 45 in this corner. So the rule is that the hypotenuse equals the leg times root 2. We talked about that last time, but that is the rule we have established. We know that the legs are the same size, and we know that the hypotenuse is the leg times root 2. So the hypotenuse would equal the leg, 44, times root 2, which is just 44 root 2. All right. Down here, this is also 45, 45, 90. If these 2 sides are equal, then you know that these angles have to be 45s. So this is 5 root 6. Remember that the hypotenuse equals the leg times root 2. So it's going to be 5 root 6 times root 2. You can do this a few ways, but like this is 5 root 12. That's not simplified. I'm going to break 12 into 4 and 3. What is the square root of 4? It is whole number 2. So 5 times 2 is 10. And there's a root 3 left over. The other way you could have done it is instead of multiplying these, could you have broken this down into 3 and 2? And then you have root 2 times root 2, which is whole number 2. Same thing. You'd have 5 times 2 is 10. You would have had a root 3 left over. Both ways are effective. 30, 60, 90 rules. These are a little bit more trickier. So the hypotenuse equals the short leg times 2. That one's the easier one because it's just times 2. The long leg is equal to the short leg times root 3. That's a little tougher because you're using a root 3 there. You need to know which side is which. Well, the side across from 30 will be your short leg. The side across from 60 is your long leg, and then the side across from 90 is your hypotenuse. So we know the long leg. So using the long leg formula, we know that the long leg equals the short leg times root 3. Well, how do you undo times root 3? You divide off the root 3. I'm hoping that you can use these patterns and go pretty quickly eventually. That's the hope. So like you should get to, or I hope that you get to the point where you see a long leg and you're like, oh, I got to divide by root 3. So you know that it just looks like that immediately. Now you do have to know how to clean that up. We practiced that for sure. 36 divided by root 3, you have to rationalize the denominator. So you get 36 root 3 over 3. 36 divided by 3 is 12 root 3. Now that's the short leg. They are asking for the hypotenuse. So what do you do to the short leg to get the hypotenuse? Well, you do the short leg times 2. So 12 root 3 times 2 would be 24 root 3. That's your final answer. My hope is eventually you could look at a question like this, like, oh, I got to divide by root 3. You could do all this process in your head, get 12 root 3. Like, okay, now I need the hypotenuse. I know I need to do times 2. And then you double that. The goal is to be able to solve a 30, 60, 90 or a 45, 45, 90 in about 5 seconds. That would be the goal. That's not going to be easy. You have to be really good at knowing when to multiply, when to divide, how to rationalize denominators. Keep working at it. That is the goal. All right, we got some more problems. Mo problems. This is the hypotenuse. Again, my hope is that you can travel quickly. You would just know, hey, the hypotenuse is twice the short leg. The third leg's across from 30, so it's going to be 15 root 10 over 2. You have to divide it by 2. But if you are having trouble with that, for now, keep writing the formulas. So the hypotenuse is the short leg times 2. So on this problem, 15 root 10 equals the short leg times 2. So you have to divide by 2 to cancel that out. Well, wait. What do you do for the long leg? Well, the long leg is the short leg times root 3. So we now have the short leg. So 15 root 10 over 2 times root 3 would be 15 root 30 over 2. This is root 3 over 1. Be careful. You do not multiply the root 3 to top and bottom. No. If I'm doing times root 3, that is like times root 3 over 1. Be careful with that. Here, we know that the hypotenuse is the leg. Notice it's not a short leg or a long leg. Just these are the same size times root 2. So 58 is the leg times root 2. So how do you undo that? Well, you divide off the root 2. I'm hoping that we're getting to the point where we can do this quickly in our head. So we get 58 root 2 over 2, which reduces to 29 root 2. Here we have another 30, 60, 90. We have the short leg this time, and we want the long leg. The long leg equals the short leg times root 3. So the long leg is going to equal 14 root 3 times root 3. That's the short leg. 14 root 3 is the short leg. Times root 3 would be 14 times 3, which is 42. To walk around the edge of a rectangular lot, Isuki would have to walk 27 yards east. That would be to the right. 36 yards north. What is the length of the diagonal of his lot? So I would reduce this and make a smaller right triangle. I can divide by 9. 9 times 3 is 27. 9 times 4 is 36. So this is a 3, 4, 5. So then 5 times 9, 45 would be the diagonal. All right, there's going to be these kind of questions for sure. Triangle, square, rectangle. You have to know all three situations. Let's start with an equilateral triangle. If I draw an equilateral triangle, let's do it a little bit bigger so we can write in there. I have an equilateral triangle here. I know that the corners are 60, and when I drop it like it's height, drop it like it's height, drop it like it's height, what happens is I get two 30, 60, 90s. This happens every time it's an equilateral triangle. You just need to know that. This will happen often in this class. It says if the altitude is 54, well, this is the altitude. That's 54. Then how long is each side? So this is 30, 60, 90 rules. The long leg equals the short leg times root 3. And the altitude, if you focus on just the right triangle, not the whole triangle, just the right triangle, the altitude is the long leg. So 54 equals the short leg times root 3. So you need to divide off the root 3. I'm hoping we're getting to the point where we know that this is 54 root 3 over 3, which would be the short leg. Sorry, I don't know what I was doing. That'd be this part. This would be 18 root 3, right? 54 divided by 3 is 18. So that's 18 root 3, which would make the hypotenuse 36 root 3, which is the side of the triangle. Remember, we drew the height. The original triangle was an equilateral triangle where each side would be 36 root 3. A square. So situation number 2, you got yourself a nice square. What do we know about squares? All the sides are equal. So all 4 sides are equal and all the corners are 90. That's a square. So when you draw the diagonal of a square, what you end up with is a 45, 45, 90. These would be 45s. And they said that the square has side lengths of 51. So how long is the diagonal? What is the rule? Well, if it's a 45, 45, 90, the hypotenuse equals the leg times root 2. So it would just be the leg, 51, times root 2. And then finally, the rectangle, which actually, believe it or not, I get the most mistakes on. So I got this rectangle here. If I draw the diagonal, this does not have to be 30. It does not have to be 60. Please do not assume it's one of our special right triangles. It says that the sides of the rectangle are 3 root 7 and 18. Well, I would make 18 the longer one. Like, make it look right. Like, if it looks longer, make it longer. Right? Because 3 times root 7 is like 3 times 2 point something. That's like 6, somewhere between 6 and 9. So I know it's less than 18. So this is my triangle here. It says, how long is the diagonal? Well, I don't want to do Pythagorean theorem on those numbers. I'm going to draw a smaller version of this right triangle. I'm going to divide by 3. This would be root 7, and this would be 6. So reduce, make the number smaller, and hit it with Pythagorean theorem. Well, because we're looking for the hypotenuse, we're going to add both numbers. So that's going to be 36 plus 7. So 36 plus 7 would be the square root of 43. But we divided by 3, so we need to multiply the 3 back on, and it's going to be 3 root 43. So equilateral triangles always split into two 30, 60, 90s. Squares always split into two 45, 45, 90s. And rectangles could be a 30, 60, 90, could be a 45, 45, 90, but don't have to be either one. But they do have a right angle, and you can do Pythagorean theorem when necessary. Challenge question. The two sides of a right triangle are 3 and 6. And the reason this one's a challenge, and if you want, take a second, pause it, and try to do this without my help. But here's the deal. They just said two sides of a right triangle are 3 and 6. They did not say which two sides. So it could be the legs are 3 and 6, or it could be a leg and a hypotenuse. Now, what I know for sure is 3 is not the hypotenuse. 6 is either the long leg or the hypotenuse. 6 is bigger than 3. So there's no way 3 is the hypotenuse. So these are the only two options. So for the first triangle, I'm going to reduce, divide by 3, divide by 3. Pythagorean theorem would be 1 squared plus 2 squared. And that would be 1 plus 4, that'd be the square root of 5. But I divided by 3, so I need to multiply the 3 back on. So it could be 3 root 5. The second situation is that the hypotenuse might be 6. And if you have a keen eye, 3 and 2, remember for a 30, 60, 90, the hypotenuse is the short leg times 2? Well, isn't this a number times 2? So I know this is going to be 3 root 3. I know it's a 30, 60, 90. I know I need to do the short leg times root 3 to get the long leg. But if you didn't see that, could you divide by 3, get 1, divide by 3, get 2? Do Pythagorean theorem, but this time you would subtract. You know the hypotenuse, you have to subtract. 4 minus 1 is root 3, but you have to multiply the 3 back in. More challenge questions. It says triangle ABC is scalene. The two shorter sides are 8 and 12. Find the range of possible lengths for the longest side that would make it exist. We did this before Christmas. It was on the last test. Remember that if you have lengths of 8 and 12, you have to add them to get the upper boundary and subtract them to get the lower boundary. There's a problem here, and this is what makes it a challenge question, is they said the two shorter sides are 8 and 12. So the lower boundary is not 4, the lower boundary is 12. If I said 4 to 20, then this isn't the shortest side anymore. It says the two shorter sides are 8 and 12. I cannot be smaller than 12, because if my third side is smaller than 12, then 12 is not the shortest side anymore. And they told us that the two shorter sides are 8 and 12. So we know we're bigger than 12, but smaller than 20 because of our rules from last chapter. Which of the following would make the triangle acute? Well, we know that it has to be between 12 and 20, so that checks out. To be acute, we know that 8 and 12 are the two smaller sides. So what we would need to do is apply our property. Let me go over this real quick. There's three situations. If it's a right triangle, then we know that a squared plus b squared equals c squared. That is a right triangle. A, B, and C. Now what happens as c squared gets bigger? If this side gets bigger, then 90 had to get bigger. That would make it an obtuse triangle. And what happens as c squared gets smaller? Well, if this side gets smaller, then 90 has to get smaller, making it an acute triangle. All right. So we have 8 squared plus 12 squared. That would be 64 plus 144. 140 plus 60 would be 200, plus 8 would be 208. So a squared plus b squared is 208, and I want it to be acute. That means to be acute, I want c squared to be smaller. Well, my options are 169, 225, and 289. Are any of those smaller than 208? Yes, 13 would have to be the answer. Which of the following would make it obtuse? They changed the numbers on us, but this would be 169, 196, and 289. Well, if this is 208, both of these would be smaller than 208. Both of those would make it acute. 17 is the only one in the group that would make it an obtuse triangle. Obtuse, c squared needs to be bigger. List each triple in order. I'm not going to really work these out. You need to know your triples. All of these are just the numbers times 4. 4 times 4 is 16. 5 times 4 is 20. 5 times 4, 12 times 4, 13 times 4. But you do need to know your triples. Get them memorized. No excuses. Oh, that's the end. That wasn't enough. All right, guys. A lot of fun there. A lot of good stuff there. Make sure you do the reviews and work through them and come ready for this quiz. I know that you will. Stay warm, stay safe, make good choices, work hard, be kind to others, help people when possible. Love y'all.